questions were being thrown at me just now, asking, and I think it's great. It shows that you guys are really involved in this. So it's part of my objective, right? My goal is to get you guys involved in this. And so peer instructions, there were questions like, can it be done in big groups? Can it be done all the time? Can it be done for any topic? Can it be done? My answer is peer instruction is an umbrella. It can be done whichever topic you want, whichever area you want, at a low level or conceptual level, it's up to you. The other thing is, some of you say, can it be done throughout the whole semester? I say yes, you can, but it needs a lot of planning, a lot of preparation to figure out what you want them to do without actually telling them to do it. Then, of course, some of you will say, no, it's too much, it's too time consuming. Then you select certain topics that you feel that it may be the most appropriate. Then use that. My point is that it is not the panacea for everything, but this is just an alternative that you can use. And I find it to be quite exciting, quite effective in many ways. So it's still your decision whether you want to use it or not. For this next experiment here, which you guys are the sample here, I said I'm not collecting any data, is can you find a piece of paper, divide into two, tear it. Paperless society. Well, because I said we can do it through poll anywhere and everywhere, but I have not set it up. Yeah? Paper tak ada, pen tak ada. Okay, just remember, then lift up your hands. No, because I wanted to do it here using that, and I contacted PPKT. PPKT cannot promise that the speed, if everybody uses it, is guaranteed in this room. So we have to go back through the old-fashioned method of paper. So I want you to have, it's basically just two pieces of paper. I'm going to give you a test. The first few minutes, you answer by yourself. And then give it to me. You know, you will write your answer, individual answer. Then I will allow you all to discuss among yourselves. Then I collect the group answer. Okay? Sorry, next time I'll do this, I'll do the bring your own devices thing, because some of you did not bring your devices anyway. So now just tear the piece of paper into two. One will be, you can label as individual answer. The other is a group answer. Okay? So when it comes to individual answer, I would like you to just not discuss anything, just give your answer first, write it down, don't tell anybody, I'll collect it. And then we'll do a discussion. Remember the conceptual idea I had just now? Then you guys discuss, and then you're going to submit a group answer. How am I going to divide this into groups is, since this is kind of screwy here in terms of I can't do, we'll do by rows. For those individuals, you have to work with the row behind you. So we go rows. So approximately 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3 with Rosan, and 4 with the person at the back there. Yes. So we'll do groups of 3s and 4s. Okay? So some of you have heard of the term clickers. Okay, so Eric was the one who invented it. But he didn't patent it, he said. He regretted it because then he lost out a fortune on that because people started using it and he cannot say anything about it. So what he did was he created a software called Learning Catalytics. You can actually surf and find it. He used it in his class. It worked very well. He sold it to Pearson on the year when I went to do my sabbatical. So when I went there, I wanted to learn more about Learning Catalytics. He says, I'm sorry, I already sold it to Pearson, so there's copyright, intellectual property, blah, 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 blah. I can't really let you see that much. I can let you use it. So if any of you are interested, we have Pearson in Malaysia, right? Okay, he managed to sell it to Pearson for 20 million US. There were 4 people, and there were 3 people involved in the group. So 25% went to the university, Harvard. The other 15 million went to 3 different people, so he got 5 million. Wow. Talk about commercialization, talk about all that. So that was the software he created. So if any of you are interested, educators are free. You can log in and you say you want to register. It is free. For your students to use it, it costs $12 US a semester. Per student. So I'm trying to get a grant. I'm going to try to see if I can use it for my class. And also, let's say 50 people, what, 50 times 12, 12 times 3, 36, 36 times 50. So it's affordable, right? It's within the range of a research grant, so I can try and use it. Then hopefully after that, I can maybe talk about the results or how it is in a Malaysian context or at least USM context. Right now, I don't have that data. I'm sorry. Okay, you guys ready? This is going to be a test, individual test. All of you just write down the answer only, and then I'll collect it. So there's no process of validation yet. We're going to talk about thermal expansion. Oh, like, oh no, you know, this is so difficult. Okay. You know train tracks, right? When it gets hot, the metal expands and you can warp the train track. So thermal expansion happens here. Now, if you were to consider the molecules within the metal thing, this is how they look like normally. Okay? What happens when you heat it up? Of course, the atoms, the molecules in there expand because when it gets heated up. Okay? They are not stable at a certain orbit, they go to a higher orbit. Unless the energy is released, usually through heat or whatever, they come back down to a more stable orbit. So this is what happens. So I'm providing you the facts, right? Give you the information. So now, consider I have a rectangular metal plate with a circular hole in it. Okay, now comes the question, the test. So think about this. The fact is that when you heat up something, the molecules, they expand, right? So the individual answer which I would like to go, I'll be collecting this. What happens when you take a rectangular plate with a circular hole in it? Is uniformly heated. Question is very simple. The diameter of the hole, will it increase, stays the same, or decrease?
Done.
Okay, those of you who are done, write it down now and I'll collect the data now. Okay, thank you very much. So basically, we had 31 individuals, okay, and we have 10 groups, because the group answer, right? Now imagine what you guys went through just now. Some of you were like, no, because you're very confirmed that the answer you have is the correct answer, right? Some of you said, not sure. And then the person who is very sure had to convince you, right? It's the same. No, it increases. No, it decreases. Blah, 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 blah. You went on and on and on. I could see that all going on. You guys are all very lively, right? So, was that an exam to you?
Kind of.
It's very different stress, kind of stressless or stressless exam, right? Less stress in an exam. Okay, that was how exams were conducted in Eric's class. Because individual ones, you get the individual marks, right? So if that question just now was worth 10 marks, you got 5 marks already if you're correct. Or you get 0 marks if you're wrong, right? So that's confirmed already because he uses the software called Learning Catalytics to record, because each one of you, when you log in, has a login ID. So when you submit your individual answers, he already has the individual answers. Who said what? So if you, now is your confidence level, right? If you are convinced, whatever answer later I'll show you, you get it right, yeah, you got 5 marks already, for sure. Now if you are not so sure, you know, whether your answer is correct or not, you know for sure you're going to get 0, but you have a second chance. During the group answer, if your group had the correct answer, you get 5 marks already. Isn't that correct? So, and during this exam now, you guys could see just now, it's like it's not as much stress as a real exam. This is actually a real exam. You guys don't feel as much stress. And during the exam, you're allowed to use your laptop, you use your website, you do whatever to get information. Because you're trying to convince the rest of your group you have the correct answer. So now, if I were to tell you the answer after I got the group one, individually you know whether you are correct or wrong, right? So no one knows. So nothing to be embarrassed about, Allah, you know, shoot. But you are definitely will get some marks already, because the group answer was correct. But if the group answer was still wrong, oh dear, but you still get your individual marks, right? Okay. Obviously, you can see that there's only the 3 tries, right? I can make as many tries. Yes?
Okay, would it be fair to a person whose answer is correct, individual, but then when it comes to group, the answer is wrong?
That means...
You know, if he was to do that, he would have to got, the 10 points.
Okay, it's nothing to do with fairness and all that, because the idea was for you to explain your idea, justify your answer to the rest of the group.
Because at the end of the day, the assessment is still 100%, whether they get A or B or C.
Correct. But if you cannot justify why your answer was correct, that means you didn't know your things well enough.
But not because you don't justify, it's just that there's some in the group that says no. The collective idea that says, collective idea, 3 out of 1, for example, that says that it's right and you have to follow the group. So how to justify that?
Okay.
Assessment.
All right. So if that's the kind of a student assessment, I'm not going to just give one exam with one question like this, right? So it'll be maybe 10, 15 questions. Are you going to be saying that you're going to be absorbing every single one, or 2 against 1, 2 against 1, 2 against 1, for all 10 and 15 questions? No. Okay. You will then have to convince yourself. And then next time, the group says, okay, I follow the wrong answer, right? Because you say you had the right answer. Will the group follow again for the next test or the next quiz? I try, tengok tu, I dengar Fauzy, asyik salah. So I'm not going to listen to Fauzy anymore. And also, if Fauzy cannot justify and say, hey, the answer was this, that means Fauzy didn't know the material well enough. Because you want to test their understanding, their idea, not penghafalan sahaja, not just memorization of the facts or the information you have, right? Because in the exam is to really make sure that this person understands, not just giving the details only, right? So this is, like I said, it's just a simple experiment, but it does invoke all kinds of emotions, right? Because you feel you are invested in it. I worked hard, I studied hard, and they didn't listen to me. So obviously you need to have a better way of explaining your ideas, convincing. So that's why I only give you 2-3 minutes. The one which I saw happening many, many times is that each group will have a whiteboard, and you can see arguments, this, that, whatever it is, and then they have to explain to it. That's why group dynamics come in. And the groups are changed every single project, 3 or 4 times in one semester, to avoid things like dominance of one group. Okay? And then the other question is, for me, I'm trying to test your real understanding, not whether you memorize the facts. If you cannot convince your friend, obviously you did not understand well enough, or your friend will not follow you anymore next time. No, I followed Fauzy, flunk. Not flunk, which means I only gave you 1 opportunity, 2 opportunities, right? I should be giving you 3 opportunities. 1 individual, and then the group. The group you can answer multiple times. But each time you get the answer wrong, deduct marks. Okay, I know you're still not convinced. We can talk later about that. Okay, but this is a simple process. Okay, from, yeah.
Actually, that is, the way I see it, is a reflection of real life.
Yes.
When you are given a task, you might know, you think you know the right answer, but you cannot convince the rest of the group how to proceed or how to go back. Then you're gone in real life. So that's how it is.
And also, you will notice that when we go back to that video again, the two presenters, bad and good, right, it's a perception again. You perceive yourself as you know the thing, and yet you're not confident of yourself. But if you feel that you know the stuff and you can convince other people, that means you know your information well. Okay, let's get the results. Study group. Where's the group?
Yeah, group number 1, 3.
Okay, come. Where's the group?
This
No, I mean the individual answers tadi.
Tadi ada kat you?
Ada kat I?
You wrote down.
Oh, okay. Sorry. Individual. Okay. No names, right? 7 people said it will increase. The decrease, which means the whole gets smaller, 10 people said. The one who says it still remain the same is 14. See, so if once I tell you this information, it's like,
So it seems that the concept that you showed just now doesn't get into their mind then.
maybe. So I'm a poor instructor, you know. See, that's why I rely on peer instruction. You guys teach among yourself, not me. So again, increase 7, decrease 10, the same 14. Now, yeah?
No, what do you mean by that? Do you mean that the real answer is that it increases and the concept of thermal
This one, 3, 3.
expansion shown doesn't get into people who answer the same? Or what do you mean?
Okay. Right. Let's. Okay, remember, I have not given the answer yet. No, I didn't say which is right. That is just the polling, meaning that generally 14 people feel is the same. 7 says increase, 10 says decrease, right? I think so. Okay, now under group. Group, okay, we. Baba?
3, 3, 4.
Okay, so group, we had about 10 groups. 3 says is the same. Number 1 is 3 groups says this increases. The 2 also 3 groups. And then number 3, 4 groups. See? 4 says it decrease, which means the whole gets what, bigger or smaller? See, now this is where the polling comes in, right? So as you can see, even with the group, tak sampai consensus lagi ni. Because you didn't convince enough. So now everybody's like, okay, validation now. Explanation. Some say, oh no, it cannot be right, no. See, now you guys are still discussing, and the person who got it right, see, I told you. Or you will say that, okay, see, this is what happens. Now, think of the process, not the answer, okay? Think of the process. You guys were trying to convince each other. You guys were trying to figure out what was the right answer. If you're confident of yourself, you think, so this is group. The next question, I can form a different group. You have different dynamics already. So now why does it increase? The whole does it increase? Okay, consider the atoms at the rim, right? Which means now, inside there, are there atoms of the metal? Kosong kan? Because the whole. When you heat up something, the atoms of the metal will expand. So if the whole gets smaller, it decreases. Right? But then, when you are actually heating it up, it expands. Because the metal atoms are not there in the air. So it has to go out that way. So the hole gets bigger. Right. So that's what she says is correct. I know this is physics again. Some of you may already know physics, so sorry. Easy only.
What about the argument that the molecules in between that is also expanding and pushing the atoms at the circle
Okay.
side and then maintaining the size because it's circle?
Obviously, he's not satisfied, right? He's not satisfied. So, hey, you can read up more about it. Yeah, you can Google it. You can go to the websites and check. Okay. So actually, that was the end for it. But this is something, another fun thing for you to also think about.
Berikut adalah cara-cara membuat kuih buah Melaka. Bahan-bahannya, 2 cawan tepung pulut, 1 keping gula Melaka, 3 helai daun pandan, 1 cawan kelapa parut, sedikit air kapur dan sedikit garam. Cara-caranya, pertama, kisar daun pandan yang dipotong bersama sedikit air hingga hancur. Selepas itu, tapis dan ambil airnya. Setelah itu, potong dadu gula Melaka. Kemudian masukkan sedikit garam ke dalam mangkuk kelapa parut dan gaul hingga sebati. Seterusnya, gaulkan tepung pulut dengan sedikit garam, air kapur dan air perahan daun pandan tadi. Tambahkan air dan gaul hingga membentuk dough. Selepas itu, ambil sedikit dough, lepirkan dan masukkan sebiji kecil gula Melaka di bahagian tengahnya. Rapatkan tepinya supaya gula tidak terkeluar dan bentukkan bulat. Ulang proses yang sama hingga semua dough habis dibentuk. Sementara itu, didihkan 4 cawan air. Setelah selesai membuat kuih tadi, masukkan ke dalam air mendidih dan biarkan seketika. Kuih akan kelihatan terapung apabila sudah masak. Kemudian angkat dan toskan airnya dan terus masukkan ke dalam mangkuk berisi kelapa parut tadi. Golek-golekkan hingga permukaan kuih diselaputi dengan kelapa parut. Kuih buah Melaka sedia untuk dihidang.
Okay, my question. Kenapa dia timbul bila dah masak? You want to watch the video again? Huh? Ya, bila dah masak dia timbul. Kenapa? Okay, when the glutinous balls float when cooked, is it a mass and the sugar dough change? Does the density of the dough has changed? Or trap air bubbles from the sugar is released? So now, like I said, this is actually tambahan. You can go on the website now and look whatever you do and find the answer. I'm not going to tell you. But basically that's my ending for today's session, just to provoke your thinking, to think of the processes that we can do with peer instruction. You actually experienced some of it, and some of you are still very, yeah? Okay, I'll give you a formula. Density equals to mass divided by volume. That's the hint. Look for, using that, you can solve this. Okay, so that's it for me today. Any questions, I'm happy to answer. You can go to the Eric Mazu group. All his talks and all his papers are given free from his website. You just have to give your email, and then automatically allows you to download, and it will also update you of any new information. So please, if you're interested in peer instruction, go to Eric's website and then look through it. Like I said, you experience it. I hope it wasn't dull for you listening to me all the time. Ngantuk, your brain activity actually went up and down a little bit, and still some of you are not convinced, no, the hole is bigger, the hole is smaller, whatever, right? So this is all misconceptions. So when we're talking about this, you can talk about higher order thinking, or it can be just a simple low level also, right? So you can use local examples. I have different examples on why roti canai, to expand it, you put more oil. Chapati, you add more flour. If you look at them, whenever they want to roll the chapati bigger, they put more flour.
So the analogy, if a stubborn student in the class So how are you going to make it more?
See? So that's one thing. Or even when the mamak stall, you see, whenever they boil water, there's a container which has 2 compartments. I've asked them, why do you have 2 compartments? Oh, lebih cepat. Is it true? You put, one is boiling water, one is they put new water. So that, but then when the heat transfer from that to that, just like another question I can give you. I masak nasi, right? Rice and water in one pot, water only in another pot, heat it up, and then which one loses heat faster? Which one cools down faster? That's in geography also, you have that. Sea breeze, land breeze, and all that. So in other words, it can be used for any kind of topic, but it needs a lot of preparation, a lot of thinking, trying to figure out, and it's very good for higher order thinking and trying to get rid of misconceptions, because you guys are discussing among yourselves. Okay? Yes?
Don't you think that students will get bored once they get used to it?
No.
It's just like a case study, you know. Once you master the case study and how to do it, and then it comes in easy. You know, you get bored, then you know, like, okay. So if it goes on like this all the time, then different concepts, different problems, but the process is the same. You go in, you discuss, you go up, you go in, it becomes like a routine kind of thing. Students will get bored.
Actually, I did not see that happening at all, because the other things are still going on. The project base is still going on. The quizzes are still going on. The exams are going on, and they have to read the book. Different chapters have different things, and the main idea is to discuss among yourselves. And he changes the group every time. So
the other thing right now, you think that people are using is pitching, you know, all pitching, and it gets very and tiring. Not only that, you know, every time once you're done, you go out and pitch. Like what you did just now, right? So you should get one of the group members to go and pitch, to pitch, and that's it. So it becomes a routine kind of thing.
well, you can try it. No, I mean, yeah, you can try it and we'll see what happens. Like I said, I'm also still trying it out here, and maybe later I can give you the results. Maybe you're right. It doesn't work all the time. It only works for certain topics better. We have different cultural things here, you know, respect elders, or tak mau argue sangat, and all that. Right, you know, you heard of Malaysian students going over there, they don't talk as much until much later, they get used to the system there, they only voice their opinion. So, hey, I'm still learning myself. Thank you. Yes?
I think one big challenge to do this is really, to get students engaged in discussion is to get to choose the right questions. Questions that involve motivation and excitement can engage class much better.
True.
Have a straightforward questions, and normally I think especially if you focus on questions that are at the lower levels of groups, memorizing knowledge on the information system rather than concept questions. Okay, that's in general my opinion on this. The question is, I read some of Eric Manzur, and then also in terms of active learning, they suggest you to do, if you want to get students engaged, if you have to do short discussions, you know, not long discussions. But that doesn't work well in my field, which is engineering, and where we have a long, big problem that needs to be solved for a long time. So following, you know, the concept of approach peer instructions with short time, we cannot apply that like think pair share. We cannot apply that on big problem solving. But what I've done in a couple of weeks, I'm a believer in peer instruction. I try to do that. I get students, you know, do simple whiteboard discussions with markers, and then on big problem, I split them up into 2 students average and then 3 students. And it turns out everything is going on their own. I try to tell them, okay, time's up now, but they keep going on. And to a point that 2 students, you know, I say, what are you doing now? You know, like right now, we've discovered this, but what I'm trying to do is try to have the other students explain it. So, you know, things are going on their own, so it's great. So.
Okay, thank you for sharing that. Yeah, it's true. In the sense that you have to do a lot of preparation. It's not a simple, buat question itu you bagi. No, you have to do a lot of A lot of thought have to go into it. But once you get it going, then like you said, the students actually get it going themselves. You have to guide them slowly. But once it goes, to start is not easy, and there are many cultural things which you have to take into account, which, that's why it's still a very interesting project for me to go on. And the thing I find it funny because you say it's from your field of engineering, and yet Eric is from engineering, and he uses it for his engineering classes. So, thank you.
Quick question. I used to remember there is a term called collaborative learning. Is this a subset or peer instruction? Collaborative learning, is it?
Okay, question was, is collaborative learning a subset of peer instruction? Or it could be the other way around. If you talk to Eric, everything is peer instruction. That's his passion, his idea. He's been doing it for 20, 30 years. So anything peer instruction, peer instruction. So to me, it's just a label. All right? The idea, the concept is there. It may be called different things. It could be problem-based learning, outcome-based learning, group work, I don't know. So, same domain.
Another one.
Yes.
I feel like anytime you want to do some kind of a transformation, this is a big thing. It should start at an early age. I noticed at primary school level, these kids, they are very open to all the stage. Is the movement starting at that level, or is it starting at a higher age?
Actually, it would be great.
Yes, this is ideal.
True. If we can use it in school, it would be great. I was fortunate that when I was there, my children were growing up. So, they had to do this weekly show and tell, which is basically you go and talk about it. So they are so used to that culture. When we come to Malaysia, instead of doing divergent thinking, we do convergent thinking. One size fits all. That's the sad part. So hopefully with this PBS and all that, it will slowly grow. But at the present moment now, it is difficult. And so we are at the university, we try it out, see if it works. Okay, but it is, they are so used to cikgu cakap, diam, you follow cikgu kata. So these are cultural differences. Jangan cakap, diam, right? And the kids will be running around all over the place.
Now the kids are not like that. Even in the kampung school, if the kids want to talk, only the teacher doesn't let it. Once they let it, I don't have any.
Yeah, so, of course, that's why we have this series of talks, right? Everyone presents their own ideas. It's up to you to absorb whichever one you think is applicable and the ideas, but things are constantly changing. All right? So that's the only thing I know about instructional technology. Never stay still. Keeps on changing.
Can you just comment on one thing? We are going towards active learning, collaborative learning, but there's a big direction going towards e-learning. Everything's using tools rather than using the old traditional method. And there are parts of the things that we learn require students to actually do the thinking and do things by hand rather than using digital tools. And sometimes learning one aspect, and when they're doing it using digital tools, they sort of cut short the things they're supposed to do. So for example, even discussions, interactions are short bursts of small talks only. So,
Okay, my comment would be use the right word, tools. Technology is a tool. How you use it, different. Like just now, I didn't use the so-called polling thing. That's a tool. I could have done it quickly and say, how many percent give this, how many percent in real time. I didn't have time to prepare it properly. But these are tools. The actual learning still has to happen to the person. So don't use it as a replacement, but use it as a tool. Okay, thank you. Assalamualaikum.